Hello again. In this video, I'm going to go over this homework problem from 5.4. And so in this problem, it says find the point or points at which the function f of x equals 5 minus 2x equals its average value on the closed interval from 0 to 2. Okay, so let me show you how you can work this out. Okay, first of all, if you were to graph this function, it's just a straight line. The graph of that line would look like this. Notice that the slope of this line is -2. So it's down, it has a downward slope, and the y-intercept is at 5. Okay, so this is a rough sketch of the graph of that function. Now, what we're supposed to do is, first of all, we're going to find the average value of this function on the interval, the closed interval from 0 to 2. And we denote that with f with a bar on top. That's known as the average value of f on the interval from a to b, and this is the formula for finding it. Okay, and then after we find the average value of f, we're going to find at what x value does this function equal its average value on the interval from 0 to 2. Okay, but let's find the average value of f on the closed interval from 0 to 2 first. Okay, we're going to do that by using this little formula. Okay, notice here a is the number that you start off here on your closed interval, and b is where it stops. So a is 0 and b is 2. Okay, so this is going to be 1 over 2 minus 0 times the definite integral from 0 to 2 of this function. Okay, so let's find this definite integral. Now, we're going to find this definite integral using the fundamental theorem of calculus, which says that if this function is continuous on this interval from 0 to 2, then we can evaluate this definite integral by finding any antiderivative of this function here, and then evaluating it at the upper limit, and then subtracting off what we get when we evaluate it at the lower limit. So the first thing we're going to need is to find any antiderivative of this function, which, by the way, is continuous from 0 to 2, right? You can see that it's just a straight line. Okay, so it's continuous from 0 to 2, and so we're allowed to use the fundamental theorem of calculus to evaluate this definite integral because it is continuous from 0 to 2. Okay, so let's find, we need any antiderivative of this function here. Okay, so the antiderivative of 5 would be 5x, and then the antiderivative of -2x, you could just use the power rule. You would add 1 to this power, so you'll get x squared, and then divided by 2, and then that gets multiplied by this -2 in front. But you can see these 2's cancel, plus any constant. Okay, that would be the whole family of antiderivatives, right? You could add any constant to this to get any antiderivative for it. So let's pick the easiest constant to work with, which would be a constant of 0. Okay, we just need 1, right? Any antiderivative would work. We're going to use the easiest one, and that's when this constant is 0. Okay, so we're going to work with this antiderivative, 5x minus x squared. Okay, now all we need to do now is evaluate that at the upper limit minus what we get when we evaluate it at the lower limit. So let's find f of 2. Now when we plug a 2 into this, we get 10 minus 4, which is just 6. Okay, and then f at the lower limit, f of 0 is just 0. So this definite integral is just 6 minus 0. And then times the 1/2 in front. Okay, again, this is a 6 and this is 0, so you get 6 minus 0 times 1/2, which of course is just 3. And so that's the average value of this function on the closed interval from 0 to 2. By the way, we denote the average value of a function by putting the bar on top. Okay, so this stands for the average value of f on the closed interval from 0 to 2, and it turns out to be 3 in this case, which is right here. Okay, so I'm going to draw a horizontal line at that point. So y is equal to 3, right, is a horizontal line, so it would be about right there. That's where the average, if you were to average this function out over this interval from 0 to 2, so I'm going to stop it at 2, it would average up at 3. Okay. Now there's another way to look at this, which I think is kind of interesting. If you look at this definite integral right here from 0 to 2, right, just this part right here. Remember, definite integrals give you the net area trapped between the function and the x-axis, starting at this lower limit and ending at this upper limit. So this turned out to be 6, right? So the net area trapped between the function and the x-axis from x equals 0 to 2 apparently is equal to 6. Now, graphically, all right, here's the function. So the area trapped between the function, the net area trapped between the function and the x-axis from 0 to 2, right, if you were to draw it out, would be this area in here. Okay, and so apparently that's equal to 6, right? That's what this definite integral is giving us. Now, let's say you wanted to maintain the same amount of area trapped between some other function and the x-axis, the same net area. Okay, so let's say we want to maintain a net area of 6. And so the question is, what would the function be that remained constant the whole time, right? We want a constant function that would give us the same amount of net area trapped between that function and the x-axis. And the answer is, it would have to be at y is equal to 3. So notice that if you were to find the area trapped below this function, or between this function and the x-axis, the net area trapped between this function and the x-axis from 0 to 2, the area trapped in that little rectangular piece would also be 6, because this is just a 2 by 3, right? This distance here is 2, and this distance here is 3. So it's a 2 by 3 rectangle, which also has an area of 6. Okay, so that's what the average, that's one way of looking at the average value of f. It's the constant number that would maintain the same amount of area that you have for this definite integral. Okay, and so in this case, y is equal to 3, right? That function, y equals 3, would be the average value where you maintain the same amount of area between the function and the x-axis on the interval from 0 to 2. Okay, so just to finish this off, the last thing we have to find is now what we're going to do is we're going to try to determine where this particular function is equal to its average value on the closed interval from 0 to 2. And that's easy to do. We know that its average value is equal to 3 on the closed interval from 0 to 2. And so if we just take this function and set it equal to 3, we can solve for the x value where that happens. Of course, right? That's what this overall question is asking us, is when does the function equal its average value? Okay, so in other words, when does this function 5 minus 2x equal to 3? And we can solve for that, right? Just subtract the 5 over. And then divide both sides by -2, and you can see that apparently it occurs when x is equal to 1. Now let's see if this makes sense. Let's just check it. What's f of 1? Well, f of 1 is equal to 3, and that's this ordered pair on this line right here, there's a bunch of ordered pairs. When x happens to be 1, the y value at that point is 3. So that's a point on the line, right? 1, 3. And that just happens to be the point at which this function intercepts its average value of 3. Okay, so it occurs when x is 1. Right? The average value of the function is equal to f of x when x is 1. Okay? Okay, I hope you found this video helpful. If you get a chance, I have some other videos that you can look at from the homework, and hopefully they're helpful as well. Okay, until then, thank you for watching. Bye-bye.